Hi everyone. Today we're going to talk about how to calculate the area between two functions. So essentially in AP Calculus AB and AP Calculus BC, you need to know how to calculate the shaded region, which is the area between two functions. So to define this process, we can begin with this definition. So if f and g are continuous on the interval a and b, and g of x is always smaller or equal to f of x for all x values in the interval, then the area of the region bounded by the graph of f and g and the vertical lines x equals to a and x equals to b is defined by the following function. So the region bounded by the graph, this is a fancy term, but it's just saying the area between the two functions. So basically, it's just area equals to integration from a to b, and bracket f of x minus g of x. So let's begin with talking about a basic one here. I believe you guys all know how to do this, but let's just start from the easiest one. So to just follow this formula, we can do area equals to integration from from 1 to 3. Or actually, okay, I got a graph here. Actually, we can just do from 0 to 2. So I can draw on the graph later. So integration from 0 to 2, and okay, let's do a large bracket, 3x squared minus 0. Because there's not another function, so basically you can put 0 inside of g of x. So this 0 is for g of x. Well, normally when you guys do this integration, you guys probably don't write a minus 0 here, but I just want to show you the concept of minus g of x here. So this equals to x cubed of 0 to 2, which is 2 to the power of 3 minus 0 to the power of 3, which is 8. So this just means that here to here. So the shaded region from 0 to 2, this is 8. Alright, so let's actually dive into this area between the two formula thing with question 2. So f of x equals to 2 minus x squared and g of x equals to x. And I also got the graph for you here. And here's the case when they don't tell you where's the bounded line, where's the bounded vertical lines, and you need to figure this out by yourself. Maybe they'll just give you this these two functions here, and you basically just need to find out how they are bounded vertically. So here's so let's talk about this in a simple way. So you basically want to make the two functions equal to each other. So 2 minus x squared equals to x. So negative x squared minus x plus 2 equals to 0. And negative x plus 2 times times x minus 1 is 0. So x is negative 2 or 1. So as you can see in the graph also, it's the two functions are bounded by x equals to negative 2 and 1. So in this case, you basically just algebraically solve the function. And now you will use the formula. So area equals to integration from negative 2 to 1, and f of x, which is 2 minus x squared, minus g of x, which is x, and d of x. So here is just gonna be equal to negative x cube over 3 and minus x squared over 2 plus 2x from -2 to 1. And this equals to, let's see, this equals to 9 over 2. For the sake of time, I'm just not gonna expand this calculation because I believe that you guys can do it. And I just want to show you how this area between two functions works conceptually. So I want to make this video really fast. So this means that the area bounded by the graph, so this shaded part is 9 over 2. Alright, so here's the third case, which is a pretty hard one. So you can see that in this case, sometimes f of x, which is this black line, is on the top, while sometimes the blue line, g of x, is on the top. So here's the time that you need to find out when is which function on the top and when is the alternative case. Because you always want to use the upper function to minus the lower function. So here you also solve the function algebraically. So let's do 3x cubed minus x squared minus 10x equals to negative x squared plus 2x. And this is just 3x squared minus 12x equals to 0, which is basically 3x, x minus 2 times x plus 2 equals to 0. So x is negative 2, 0, and positive 2. Alright, so you can see that between negative 2 and 0, f of x is in the top. And between 0 to positive 2, g of x is in the top. So in this case, we need to integrate by two parts. So the area equals to integration from negative 2 to 0, f of x minus g of x dx plus 0 to 2, g of x minus f of x dx, which is opposite. So this is because we always want the upper region, upper function to minus the lower function, right? Yeah. So to substitute the function in, here's the method. X, which is equal to negative 2 to 0 plus 4 plus 6x squared 2. Alright, so this is basically negative 12 minus 24 plus negative 12 plus 24, which is just 24. So here's a more complicated case. Just remember always to minus the lower function with from the upper function. Yeah, and here's the last case. So it's a situation where it's f of y and g of y. It's basically the same concept, but just to be careful that in this case, it's the one on the right minusing the one on the left. So here's the area should be still using the function. So it's negative 2 to 1 negative. Yeah, negative 2 to 1. So in this case, it's a bounded horizontal line, as a bounded horizontally. So here, y equals to negative 2, and here y equals to 1. So it's from negative 2 to 1, also from the bottom to top. Alright, so it's just 3 minus x squared minus y plus 1 dy. So negative y cubed minus 3 minus plus 2y, which is negative 1 over 3 minus 1 over 2 plus 2 minus 8 over 3 minus 2 minus 4, which is 9 over 2. So the bounded region here is 9 over 2. So in terms of y, just be careful that it's bounded horizontally for the two horizontal lines. So you use the y-axis value to do this integration, and also you use the right part, the function in the right to minus the function in the left, but it's still in the same formula as the previous ones. And I think that's basically all for the area. Thank you very much.